This is problem 1 of exam 3. Problem 1 reads, find the absolute maximum and minimum values of f of x equals e to the x cubed minus 3x plus 2 on this interval, 0 to 2, including 0 and 2. I wrote something here to recall real quick. When looking for the absolute min and max, we must consider the endpoints as critical points. So when we do our first derivative test and make it equal to 0, and find the possible critical points, we also must consider 0 and 2 as critical points. Alright, so let's start this problem. So first we need to find the first derivative. So let's find the first derivative. Okay, the derivative of e to raised to the anything is e raised to the anything. So that's e x cubed minus 3x plus 2 times the derivative of that anything, in this case is a polynomial, so the derivative of polynomial is use the power rule here, so that'd be 3x squared, so this times 3x squared minus 3, and the third is 2 is 0, so that's that. Alright, so using the first derivative test, we've got to make this equal to 0, so e x cubed minus 3x plus 2 times 3x squared minus 3 equals to 0. Now we have something times something equals 0, so either this is equal to 0 or this is equal to 0. However, e to the anything can never be 0, so we ignore this part and we just concentrate on this one. Alright, so now move 3 over, divide both sides by 3. We get x squared is equal to 1. To solve for x, take the square root of both sides. Take the square root, you have plus or minus. Therefore we have that. Our possible critical points, so possible critical points are x is equal to plus 1 and x is equal to minus 1. Square root of 1 is 1, so you have plus 1 or minus 1. Alright. However, minus 1 is not on this domain from 0 to 2, so that's gone. And 1 is on this domain, 0 to 2. 1 is defined on this function, f of 1 is defined, so x equals 1 is a critical point. Definitely a critical point. So now we have a critical point, and we also have 0 and 2 as critical points because we're looking for the absolute max or min. And we recall that we have to consider the endpoints as critical points. So if I draw my number line here, okay, we have 0, we have 1, and we have 2 as our critical points. Now we're going to test points here. Pick 1/2, and I'll pick 3/2. Okay, so those are my 2 test points. So I want to compute f prime of 1/2, and look at the sign. I want to see what's the sign, because the sign will tell us if it's increasing or decreasing. So f prime of 1/2, come here to f prime. So that would be 1/2 cubed. So e 1/2 cubed minus 3 times 1/2 plus 2 times all this. By the way, this will always be positive. So this is all positive times 3 to the 1/2 squared minus 3. Alright. What do we get here? Let's work with this. We get 1/4, so we get 3/4. So 3/4 minus 3. It's going to be 3 minus 12. That's going to be a negative number, so we have negative here. Let's see, will this be positive? I said positive, let's see. Yeah, because we get e to the negative something. If this is negative, we get e to the negative some number, and that'll be 1 over e to that number. So this is positive, this whole thing is positive. So we have a positive times a negative, because this was negative. Here we have 3 minus 12, so this becomes a negative number. So f prime of 1/2 is a negative number. Alright, so that means we have something like this. So it's decreasing, right? On 0 to 1, that interval. Now let's compute f prime of 3/2. Okay, again, this will be positive, so we have e 3/2 cubed minus 3 1/2 3/2 plus 2 times, now we have 3 times 3/2 squared minus 3. Now we want to see if this number is positive or negative, because we already know this is positive. This number is positive, we have positive times positive is positive, that would be good. That means that from 1 to 2 it's increasing. If this number is negative, we have negative times positive, therefore on the interval 1 to 2 it would be decreasing. Alright, so let's see. This is 9 and 4, so we'll have, so this is 9, 4 times 3 minus 3 over 1, so that's 27 over 4 times 3 over 1, LCD is 12, yeah, so this will be, 4, so this would be 27 minus 12, that's a positive number, so this is positive times positive, so f prime of 3/2 is a positive number, so that goes like that. Okay, so what does this mean? That at 1, there's a min, right? So at 1, at x equals 1, there's a minimum, the absolute minimum. Because here at 0 and 2, there's maximums. But we want to see which one is the absolute max. Alright, so first let's go with the 1, that's our minimum. Let's go erase this. So, min, or absolute min, absolute min at x equals 1, and find the absolute max. Okay, so x equals 1, and now let's find what it is. So f of 1 is what? Come here, right there. So f of 1 would be e to the 1 cubed, that's 1, minus 3. 1 minus 3, so it'll be minus 2, plus 2, 0, and we have e to the 0 is 1. So that's 1. So that's our absolute min. Absolute min happens at x equals 1, and the value is 1. Now let's find the absolute max. Alright, so the absolute max. There's a maximum at 0 and 2, but we need to find which one is the maximum. How do we find that? Well, we compute f of 0 and f of 2 and see which number is greater. So let's compute f of 0 first, though. F of 0 is 0 cubed, is just e squared. So that's e squared. Now let's compare that to f of 2. So what's f of 2? That's 2 cubed, that's 8, minus 3 times 2 is 6. So 8 minus 6 is 2, 2 plus 2 is 4, so that's e to the 4. So clearly we can see that f of 2 is greater than f of 0, therefore the absolute maximum happens at x equals 2. So that is that x equals 2, and that exact value is right here, f of 2 equals e to the 4. So that would be our absolute max. Alright, so that's pretty much it. So let's recall real quick. So remember, when looking for absolute min or max, we must consider the endpoints. So they give us this domain. We must consider 0 and 2 as our critical points, which we did here. We also must find the first derivative, make it equal to 0 to find our possible critical points, which we found was 1 and negative 1. But negative 1 was found in the domain of 0 and 2, so we have to exclude negative 1. F of 1 is defined. If you put f of 1 here, it's defined, so that's fine. So that's a critical point. So x equals 1 is a critical point, so we put it here. With the 0 and 2 are endpoints, 0 and 2. We do the first order test, so how we evaluate, we grab test points. So 1/2 and 3/2, 0, 1 I put 1/2, and 1 and 2 I put 3/2. Now I tested these two to look at the signs. If I know it's a negative sign, so if I plug it into f prime and I get a negative sign, I know it's decreasing on that interval. And if I get a positive sign, I know it's increasing on that interval. So from the interval 0 to 1, it was decreasing, and from the interval 1 to 2, it was increasing. So therefore the graph has it's opening up pretty much at 1. So there's a minimum at 1. Okay, so since there's a minimum at 1, that's the only absolute min from 0 to 2. So the min is automatically 1, x equals 1, and the value is evaluated. You obtain a value when you evaluate 1 to the original function, which you get 1. Now we have 0 and 2. These are possible maxes, but we want to find which is the absolute max. So we must compare f of 0 and f of 2 and get the biggest one. We got that at x equals 2, we got e to the 4th, which was greater than e squared. So that's that. Alright.